एक मिनट रुक जाओ, रेडी होने दो. चलो ये कर लेते हैं. This could be a great intro.
Hi, I'm Akshay.
Hi, this is Saurabh, and you are listening to the Founder Thesis podcast. We meet some of the most celebrated startup founders in the country.
And we want to learn how to build a unicorn.
Hi, this is Gokul.
Hi, this is Nikhil. We are co-founders at CynLr, Bangalore-based deep tech, robotics and machine vision technology company.
Terminator was one of those sci-fi movies that really influenced a whole generation of tech nerds and innovators. While we all agree that a Terminator-like robot is nowhere on the horizon, but some of the capabilities of the Terminator are now available in commercial robots. And one of the biggest game-changing technologies in the field of robotics is the science of machine vision. Traditionally, replacing humans with robots in factories has always been an expensive and lengthy process. In fact, Tesla blamed the robotics in their factory for production delays. But thanks to the work done by Gokul and Nikhil, the co-founders of CynLr, this may no longer be true. They're building the next generation of factory robots that would change the manufacturing landscape in ways that we can't even imagine today. Listen to this fascinating, mind-boggling conversation between the founders of CynLr and Akshay Dutt about a future in which robots with intelligent vision fundamentally alter the business landscape.
So even without having a very solid product goal or a business goal in mind, Gokul and I took the step of leaving our jobs at NI in 2015. While at NI, we had already identified that there were a lot of customers wanting to solve their automation challenges in manufacturing plants using machine vision, but were terribly failing. And I had 10 problems and I would succeed in 3, 7, and I would fail. Right? So we knew that there were the 7 customers or 7 customer use cases that were unsolved.
So you quit your job to be consultants. The goal of doing consultancy was essentially to discover what could be a use case for this insight which Gokul had. And how did you get these consulting assignments, and were they well-paying assignments?
Yeah, so when we were in NI itself, we kind of recognized that there were a lot of customer use cases where the customer wanted a solution, but the available technology in machine vision was limiting. The technology would kind of more or less unsolved. So we had the opportunity to kind of cherry pick some of these previously unsolved problems from customers.
And the customers already trusted you because you were interacting with them as part of TI.
We also did our own efforts as well. So we got a few of our existing relationships. So I found a project in GE, for instance, that I was working with, and Gokul was working with one of the largest grain milling equipment manufacturers in India while we were in NI, and then he was able to kind of convert that into a consulting project as well. We got some leads from other manufacturing customers. All of them, the goal was for us to identify what are all the use cases where machine vision can play a role. Machine vision can play a role in physical interaction, some kind of manipulating objects in the world. And then we let ourselves discover what kind of use cases will get paid for, what kind of use cases customers want to be solved really badly, really immediately. And over the next 3 years, we ended up developing and delivering over 30 previously unsolved custom machine vision and robotics projects.
Okay.
And it turned out that a majority of these use cases came from discrete manufacturing automation, right? So wherever there is a certain set of objects being put together, and you need to automate that task. Today it was extremely challenging for manufacturers to do that, and that's where we got most of our use cases.
So what does the word discrete mean here?
Discrete manufacturing is any manufacturing process where individual components have to be handled, put together. Automotive manufacturing, for instance, is an example of discrete manufacturing. You have about 10,000 discrete parts that go into a car, each of the metallic parts or plastic parts or glass parts, and each of these has to be picked, oriented in place, right? Process manufacturing is something like petrochemicals and cement manufacturing where you don't have these discretized units where it needs to handle. Most of that is already mechanically automated because you don't have to really individually handle any components. You can put them in containers and the containers can be standardized. Whereas when you come to discrete manufacturing, the car models keep changing, the parts that you're handling keep changing. smartphone manufacturing, for instance, every 12 months, every 18 months, you get a new set of parts to be manufactured and assembled. In all of these use cases, it was extremely challenging to deploy robots as they existed today, because robots inherently are blind. They can't see where these objects are, and for you to really get that robot to automate something that otherwise is fairly simple for human beings was super challenging. And we found these use cases through the projects that we did. And while doing these projects, we were largely relying on off-the-shelf hardware, but putting those off-the-shelf hardware together on a case-to-case basis using our fundamental approaches that differed from how the machine vision world or computer vision world otherwise dealt with it. And we were able to achieve 100% success rate in every attempt that we did, every project that we took up. And that's when we were able to kind of validate that our approaches were strong. But we still were doing this in a consulting manner. We were still doing that in a customized manner, relying on off-the-shelf hardware, because of the off-the-shelf hardware was built for identification, did not have the abilities like convergence and autofocus that we really wanted. And therefore, through this process, we were also able to go ahead and identify and articulate what is the hardware product that we had to build to universalize this or generalize this altogether. And that definition came to shape by early 2019 for us. So by early 2019, we knew the exact product that we had to make. We knew the exact stack that we had to build, both on hardware as well as software. We had also identified customer use cases, industry that was itching to have this problem solved, which is largely discrete manufacturing. Within discrete manufacturing in India, automotive was the largest buyer and largest player to expect these innovations to come. And with all of that, we were able to go ahead. And anyway, hardware design and development, there is a gestation, there is an entry barrier, and there is a capital requirement to put together any hardware from an industrial quality standpoint. So we identified that we had to fund ourselves with some capital.
So during these pre 2019, when you were still doing consulting gigs, was it a two-man show, or did you build out a team also? And what kind of revenues were you earning annually in those years?
Right. So we largely did it as consultants. So it was Gokul's and my time, only for one of the projects, which was a more product development effort that we had to do for this grain sorting application. Probably Gokul can talk a little bit about the technical aspects of that application. We got into a deal with the manufacturer saying that they will hire a couple of resources, we will hire a couple of resources, and then go about doing the project engineering. But otherwise, it was a two-man job, and we earned enough revenues to live a standard of living that we wanted and go about discovering the problem and discovering the landscape. So we were generating upwards of about 20-25 lakhs worth of just consulting revenues between Gokul and me. And that
monthly, you're saying?
No, for the year, but our purpose was like we spent about 30% of our time consulting, 70% of our time researching and developing the product aspect. So we were very choosy, we were selective. We didn't really want to build a services business. We never wanted to do that. Our goal was to identify that we will be able to solve this problem universally, and what would be the product definition, what would be the market outreach. So you can consider it as a sabbatical time outside of NI. We wanted to search and also keep the wheels
like
rolling.
A product market fit time in a way.
Right. So discovery.
Basically, our PhD, market discovery and PhD time. So.
Yeah. Okay. PhD. Okay. So then, when you had clarity on what you want to build, this was like you had clarity that this is the hardware that we need, and was it specifically for this use case that in factories we need this kind of hardware, or was it like something generic that we will customize it as per the use case? Like how detailed was your vision on what you wanted to build?
At the starting, right? So one thing we were very, very clear is that, and from the articulation from the beginning, is that you need something, a vision that enables the hand to be able to do things, right? And when we moved from there, one thing we were very clear is that any nascent technology, we need to look at who is being profitable and who is buying a lot, right? robotic arm is not something that we were making from scratch. We are using what it is and we are building only the intelligence layer on top of it. So if I have to sell, I need to look at the customer who's already buying a lot of robotic arms, who's very convenient, and then so we had that clarity. We always began from there, right? And to say whether we also wanted to check whether are we biased by whatever the past data is? What if there are other customers who are willing to buy? So we also tried with every other customers, electronics and different cases. Mostly it always had been automotive industry which responded back with their problems, and because they are the ones who are already trying automation, right? So that market in itself revealed it to us rather than we going behind something. That where is the attraction that is highest for us, right? And considering that we are not sitting on a platform which is already well established and moving on, this is also nascently picking up technology, right? And we had a very clear difference between a platform and a product. A technology, platform, and a product. And because at a platform level, if you are selling at a platform level, you always need a solution engineering on top of it, right? If it's a product, then at least okay, so some service and support will be enough, but solution engineering might be drastically rated. Plug and play might be large, right? But most of the industrial solutions never act like a product. They always act to be a platform, and you need to kind of integrate together. So, which the industrial system already had a network of integrators and things, and we also have a structured process how to put this together and how these things can go towards. We wanted to leverage that. That's already available. So that again also happened to be automotive, which is more conducive for us to go like this, right? And they're also they're more forgiving for how nascent the tech is. Because we are a small startup. At the stage that we are now, we first initially put our money and we were running for the first 3 to 4 years. And we were doing all this and we were trying to, then we started circulating money with the customers that we got as consultancy. We were doing all that. And in the process, there were a lot of opportunities that came. We said no to them, simply specifically saying there was also tools that we were using. There were a lot of tool-based integration solutions that were also coming, right? So that also we kind of ignored. A lot of control and motion-based systems that came, we ignored them. And we never took mechanical as part of our integration. We always let the customer take care of that. And we were doing only from a vision and algorithm point of view. And specifically only those applications, right? So that I'm not innovating on the business side, I'm innovating only on the tech side. And once the tech picks up, then you can go about innovating on the business side. So then again, that when we look from that idea, then from that filter, then the automotive came to be the perfect solution from that case. So that's how we chose our customers. We started
and the idea was to build a platform which would be customized for each customer, and you would work with the existing ecosystem of people who do that customization.
Correct.
Who is the existing ecosystem of people who do customization?
That is a huge ecosystem of I mean, I can't just name one specific person because
what type of like these are like consultants basically.
No, they do the whole mechanical fabrication. They do the whole integration of those systems. So you have global level large giants like Actinium who are there. Them and so many other companies very similar.
So these are companies selling like robotic arms.
No, they robotic arms are sold by companies like ABB, Fanuc, Kuka, and all these guys. Right? So today, in fact, that brings another point. Right? If you are buying a robotic arm today, you will get only till the wrist. You won't get the hand. Right? You don't get the gripper. The gripper is an entirely independent industry like Schunk and all the other like $500 million and $200 million, $100 million, $30 million, $10 million, $1 million companies. There are a lot of those kind of organizations which are sell grippers, and most often Schunk is the largest simply because they don't give you the fingers. You customize the fingers. You customize the gripper from all of it, right? You have only the grasping technology that comes along with it, right? So that's how far the tech is today, right? So you don't have the tech that is sophisticated enough, that's complete enough, right? So this is only till the robotic arm. So you can't do anything without the gripper to handle an object, right? So it's a system integrators who start from there onwards.
Okay.
Right.
So system integrators are like small hardware tech kind of firms who will procure the arm from one place, the gripper from another place, and the software from a third place, and the cameras from a fourth place, and integrate it all based on what the client needs. Okay. Okay. And for the vision cameras, again, are there like large players who provide that, or these are like off the shelf cameras?
Yeah. Nothing on the size of like Nikhil or Sony, like multi-billion-dollar companies don't exist from a camera point of view, but several hundreds of millions of dollar companies like Basler, and from there to like 10, $20 million companies also there. Mostly they all have been brought under one acquisition wing. Today, back 10 years back, that was a lot more companies. Nowadays, there are only very specific, some 5-10 companies at the max, who are standard companies. And in machine vision, typically you don't get the camera along with the lens. Optics is a separate world of companies.
Oh, okay. Okay. So there are actually a lot of different vendors whose products need to be purchased individually. So you need someone technical who understands what the client needs, and then creates the specs for each of these products, and then integrates it all together. Okay.
Absolutely.
Okay.
Absolutely.
Okay. And what would be your role in this? You would provide the camera tech and the software.
So the whole portion of the technical person who is supposed to understand what lighting has to be there, how the lens, what is the math behind the lens, how do you choose that lens? Because there are like, if you open a lens company like Opto Engineering or Edmund Optics, right? These are all big giants of, I mean, Edmund Optics is a giant in optics from a machine vision point of view, or any custom. There will be almost like 1,000 different lenses that will be there.
Right.
How do you know which lens to pick, who to put, and what combination? Based on an algorithm, you'll have to change the lens. Based on a lens, you'll have to change the algorithm. There is a cycle that keeps going on, right? And often customers cannot spend on those to keep changing those hardware, because our camera might actually cost more than ₹1,00,000, right? The whole system might cost you anywhere between 6 to 7 lakhs. You can't just keep experimenting on that, right? So you need an expert who understands from a physics point of view and sets all of this together, and he's able to give those feedback. So that's the portion that we were doing, along with the whole software architecture and also the algorithm, right? So we will design the system for them, and the customer will purchase the hardware. We didn't want to. If that would have done, our revenue might have looked at much bigger. But we didn't do it that way. We just, because we didn't.
This was during your consulting days. You were actually like a system integrator also.
Correct. We were also so system integrator from the vision point of view, where mostly the system integration, usually there will be another company, right? So we had partners like Sasyata, we had partners like Centrix, and some organizations had in-house capacity to integrate, like CynLr, one of the customers had their own in-house capacity to integrate and all.
But what did you want to create? Like, when you started CynLr, and what did you want to create here?
After funding.
Yeah.
Right.
Yeah.
When we started in 2019, August. Yeah. So when we start, so out of these experiments, we kind of very clearly realized that, hey, our approach works, because the method by which I said this lens has to be put, the method by which this camera has to be put, the method by which whether you have to turn this way or this way to get the data, right? So all these were all kind of fixed, right? So, and we were never having, and how did we test that? We were never adjusting the system there, right? We just designed everything on the paper, and then we just put there, and it just worked in one shot, right? So the moment that was happening, then we were very confident that I have understood the way I am thinking about the problem. And then we also understood the fundamental layers of tech, what is needed to be built, right? But we didn't have an universal hardware which is capable of doing all these adjustments by itself and figuring out. How I was able to figure out that, hey, this coin, you need to put it this way and then look at it from this angle, right? That's because I was able to understand and then get it to the point, right? This intelligence needs to be fed to a device, and the device must be capable of doing all this by itself, right? So that ability was not there. There was no hardware that is available which was there at that point, right? So we need to build that fundamental layer of tech first from a hardware angle. That in synergy with whatever the software approach that we had, right? And then layers of information that our brain uses to understand all this. Some places depth, some places reflection of light, some places just on color, all these things that it is able to make a combination, make a model around it. And the ability to build that model for a system by itself is something that we have to build, right? So that's what we want to do. Only then we can standardize this business. Else, every time we are custom engineering, if you're custom engineering,
It's very manual.
It's very manual and it's not replicable.
So you wanted to create like a standard kit of lens and camera and maybe a light source also in that?
Light agnostic, mostly light agnostic.
Okay. But like lens, camera, and software, like this whole thing in a standardized kit, and then that kit can just get attached to the robotic arms, which system integrators are creating for these companies. Okay.
And what we are going one step further that we want to do is we didn't want to just keep it as a camera that is just attachable to any robotic arm. When we make a final solution, at the end of the day, the customer today, Nikhil has a nice statistics where he brings out every time, right? So this is a $48 billion industry, robotic arms today are, out of which just 30% amounting to almost $16 billion of money is just only for robotic arms, right? Rest of the 70% of the money is only for customization, right? And it's not organized. Every time it's a new system. Even replications don't happen as a replicable system, right? And they go through 6 months, 7 months of stabilizing the hardware, design, and everything, right? So why are we doing all the customization? Because today a robotic arm goes to one location. You just teach them, go to this location. Then you have a gripper which you have customized and put such that if there was an object present already in this orientation, it will just simply attach to it, right? Go to another position and then release it. When you release it, it just falls. The way it falls is the expected orientation that you wanted. So this is the entire contraption that they are building that will not fail ever, right? So that's how they have been doing. This design takes an infinite amount of time usually, right? A heavy amount of time for all of these guys, right? And this customization changes all of the system that you built. How do you bring the object to this position in that expected orientation so that your gripper is not touching this portion, but it is touching this portion, right? So that contraption that they build in conveying system and presentation system is the majority cost today, right? That's the 70% of the cost, and it's entirely customized, right? And the second problem is your robotic arm is 20 micrometer precise. Most of the cases, it's 20 micrometer to 100 micrometer precise, right? Which means you come to this position and then go to that position for next 5 years, it will keep continuing in the same position in that position, right? Some calibration in between here and there, but it will keep doing that, right? Which means if your object, if I'm making my gripper come like this, and then if my object is slightly away, it will fall on the object.
Yeah, it will fail.
Okay? You also have to present the object at that 0.1 mm of accuracy. To bring your, it's easy to just present it, but if you have to present it at 0.1 accuracy, 1 mm it's much easier. 0.1 it becomes harder. 60 micrometer, 50 micrometer is extremely hard, right? So that's when the system is able to succeed, right? This again is a problem that's where this 70% of the cost is going. That difficulty of it. Right? This we could simply standardize. A human being, on the other hand, you'll just look at it. He doesn't need the hand to be that precise. He'll come here and then he'll adjust.
He'll adjust the hand. Right.
Adjust the hand and then you want to place it because it's blind. You are expecting it to 20 micrometer precise. But otherwise, you have a shape into which it is supposed to go fit. Right? You'll just place 10 times and you'll figure out and then just put it inside. Right? Adjust yourself and then you'll put it. The more you train yourself, you will become one shot itself, you will start going and putting it, right, as it slowly goes. And the ability for the system to be more dynamic and then put it will remove all this customized structuring that is needed, right? So when I'm able to put this camera and then make the system learn, anyway, to move the camera, I need the robotic arm because I need to do all this, right? So the same system can also double into a manipulation system also. And then you are able to give a packaged solution to a customer. And customer can buy it like a laptop today. Right, variety of objects. We had variety of different devices to handle them. Just like we had variety of data in 1970s. You had a typewriter. You had your calendar. You had your theater and TV. You know, everything has become just one laptop today. All this variety of data is able to. Right, the standardization of circuits that they did into a CPU, arithmetic and logic unit, is what our next big vision is. That's what you want to do in this whole thing, right? When I have my robotic arm as a standardized unit between different objects, different orientations, and different tasks that you do, right? People can start replicating more quickly, and it makes the line more universal. That you could repurpose the line for something else, rather than having to change the whole line every time, even if a small dimension changes today, right?
In a way, like
and
Microsoft giving Windows to the hardware
Shell,
companies.
hardware company.
Okay. So you want to
That's
be
exactly, you got it exactly. That's what you want to kind of-
basically you're looking to build the operating system for manufacturing automation.
You can actually, that's what the events will. I think in the screen, we all have this one vision map, and that's the universal factory and an operating system for a factory. If you want to change something, you don't go about changing the hardware or recircuiting the whole factory, because it's just a circuit, it's just moving the objects here and there, right? So, two processing units, right? Instead, can we reprogram and then change the whole factory?
So, like, did you first raise funds, or like, tell me the journeys?
Right. So we basically launched CynLr in August 2019, along with.
And what's about? I mean, why this name CynLr? It's not a very easy name.
CynLr is short for Cybernetics Laboratories. Cybernetics. We already discussed. So it's a short form of Cybernetics Laboratories, and cybernetics is something that we, as a philosophy and as a science, we subscribe to in everything that we do on the technology. And so we launched CynLr in August 2019 along with a seed round of funding. It was about $750,000 US seed round of funding raised from some deep tech VCs based out of India.
How did you navigate that? Because I mean, you had no idea of fundraise and all of that stuff, no? Like.
We did have an idea. I mean, at least
Nikhil comes from the startup.
Yeah. So my friends from Pilani have raised a lot more money than I can imagine raising in the near future. Very close friends, batchmates, 1 or 2 years seniors. I also came from the entrepreneurial network. So in fact, our problem was not access to the VC network. Our problem largely rested on the fact that our problem and our company was not within the typical VC landscape, right? Very few people really understand the deep tech models.
You have no app.
Right. So you have to prepare an app.
Your thesis doesn't fit our problem, basically. So
there's a thesis mismatch. Therefore, although we did have access to most of the top tier VCs, there was a bit of a struggle with respect to articulating the value proposition and getting the recognition. If we had attempted to raise money when we left our jobs at NI, it would have been extremely difficult. But thankfully, between 2015 and 2019, when we raised, there was also a significant amount of churning that was happening within the VC ecosystem, not at the top tier, but at least at the seed stage, where there was recognition for the opportunities around solving for deep tech problems, very fundamental technologies that will have an IP value and a value of building business use cases in the future, and then the IP ends up becoming your significant moat. These are going to be companies where it's going to be significantly difficult for somebody to come and compete with you. If you have done 10 years of very fundamental personal research on this, you can't really reverse engineer that in 3 months. You'll have to go through a lot of experiences that we have gone through. So there were a few players in the market at a seed stage who had started recognizing this and looking for founders at that. And we were also, of course, like looking for them. So eventually we found each other. So it took much longer than what it would typically take for us to close a round of funding. We began mapping that ecosystem.
Kind of also needed a very strong deep tech people who understood their time investment into deep tech.
Right. You needed a patient investor.
We needed more than the patient investor. We also needed someone who understands and who made their thesis as something that is very specific. The current set of investors, especially the one who led, where if you look at the history of their investments, that will all be like our organizations, similar to ours, right? So they had that very strong conviction to put that money. Speciale and Arali and Grovex and all of these guys. So there are not many competitors who are exactly looking these, and that's another issue. In India, this is a very limited space, and you have a lot of ground robot systems, but we don't have many of these robotic arm based organizations. Either it will be robotic arm improvisation. They're not people who are solving this pick oriented place or random bin picking kind of problem, right? On the other hand, across in US and other places, this is a much larger problem that everybody wants to solve than in India. So that's also another problem where VCs are not aware of information. Half the times we spend more educating and rather than, and we don't have a platform to also often talk about.
So this 750,000 that you raised, what did you build with that?
Sure. So like I mentioned, in August is when we got that cash with the goal of us
August
2019. So the first goal, of course, was to crack the hardware deficiencies on the vision aspect, and then build out the software stack along with the robotic arm and a gripper that is adaptable. And then the goal was to launch something which is very dynamic, something that is visually intelligent, a robot that can learn how to manipulate a variety of objects.
Currently, you are pre-product, like you're still building this out. Okay.
Yeah, almost completed. So I mean, what happened historically is August 2019 is when we raised. Then the pandemic struck, and then we were kind of out of our laboratories for a while. But we took on our feet to.
What we are is we have built a platform, right? With the platform, we already have started engaging with the customers to collect solution use cases, so that we know what to productize this into. So it's one thing to have this technology which understands motion, it's able to move it and all that. But how is an engineer going to train it? How is the engineer going to use this to integrate into the solution? So those portions are also part of our next fundraise that we are also attempting to make it more smoother. But we already have this platform and we are testing it out with some of these customer applications and customer use cases that we actually got as a hardware that is there. I think right behind Nikhil, there are those components that are lying there, and so that's what we are at, and we want to just bring it to one preliminary shape. Not all applications can be handled with the current form factor that we have, but there is significant portion of close to $1 billion of opportunity just for the current format of the robotic arm. So that's something that we are trying to launch with the association with one of our customers. In Imtex in January 2022, end of January.
Yeah, sorry, in Intex.
Imtex. It's Asia's largest machine and machining tool expo.
Okay.
That happens in Bangalore.
Okay.
Founders, then we have tons of great stories from entrepreneurs who have built billion-dollar businesses. Just search for the Founder Thesis podcast on any audio streaming app like Spotify, Gaana, Apple Podcasts, and subscribe to the show.
And so what you're launching is like a plug-and-play product, or it will need to be further customized, or like the customization also will be like, say, ordering a computer from Dell?
On the software side. On the training on the software side, there will be some more.
So there is
hardware side is completely. So what we have achieved with this 750 case, we have stabilized the hardware platform. So you don't have to go about customizing the hardware around this device.
Okay.
But
This can handle like a range of use cases because of the intelligence around it, so it can adjust itself to different kind of use cases. Okay.
So the definition of the product that we're launching in January is a hardware platform that will scale across use cases, be able to manipulate objects. Even from randomized bins, you can just it can put present objects in random orientation. However, the system has to be trained for the objects that it is handling, right? So the training is a software training process, roughly a 2-week training process that we will do in our facility with our robotic arm, and then ship a software model or an intelligence model to that
next
robotic
phase, what we think this will lead to is we would learn out of these opportunities for us to see, hey, these are the hiccups, hey, these are the places where you could make a much better UI and tool and integration to be much more easier, and these are the places where robotic arm is limiting. So this is a learning experience for us to do that solution engineering from this, so that we can formulate it, refine it much further. So our next phase of development will be split into 2 portions. One, standardizing from the software point of view, and the next is coming up with more further deeper technology layers and further ability, which will bring more ability for the robotic arms to handle more.
Talk to me about both of these. So first one, the standardizing software means that 2 weeks of training will come down to maybe a couple of hours of training. That's what would happen in the next.
And that journey we see. So our eventual thing is in 4 to 5 years time, we will reach 1 day of training, right? So in fact, we split them into 2 kinds of training. One is the object model training. The other is task training. Task training is fairly quickly achievable. But object model training takes a lot more time today, right? So at least take 2 weeks to one month, right? Based on object to object or task to task, right? So that we want to standardize and then shrink it down to.
How do you train?
Again,
How does it, like you're going to train for 2 weeks? What will you do in that 2 weeks?
So there are different procedures, just like a baby, right? So we are going to accelerate, and then for a baby, it is learning a lot of sophisticated environment. One advantage these robots have is they are in a limited environment where they are to learn. They don't have expectation to look anywhere else. They don't have expectation to, pick another part or somebody comes, stop them. None of those things are actually there. So how do I first then differentiate it without touching it? How do I know? Because there are a lot of shades and colors and formats that an object will have. So how do I know where to go and touch it? Where should if I grab it, it'll be able to grab it. Or am I looking at the pattern of the wood in the table as an object? Or is it the whole object itself? Am I picking the contour of the object, edge of the object, right? So those things are all touched. So it will start from there. Slowly, there is some procedure for it to get there.
And this training happens how? Like this is purely you sitting on a laptop and feeding it images, or is it like actual?
No. There's an object. There's an object.
Okay.
Real object in front of the camera, in front of the robotic arm. In fact, it looks at it, it says, and then it goes and touches it, and then it validates. Oh yeah, the contour that I saw is rigid. The contour that I saw is not. So all those things it will learn.
So it actually feels like watching a baby learn. Then, like you actually see that arm touching, learning, getting more confident each time. The speed at which it happens, getting shorter and shorter. Mistakes.
And if I turn it, this looks like this in the other side. This side it looked like this. So all that portion of it learning will be there. Right now we are doing like motion sensing and these kind of things, right? So the way it associates force and the way it associates all that information that is there, right, about an object. We say 7 different parameters of the object that is supposed to understand and then associate them together. The method of association, how it is constructing depth today, how it's able to utilize autofocus, how it's able to utilize the convergence, how deep is it actually taking its understanding, right? Understanding the color, understanding the texture, so many of those things, right? So those are further layers that the system has to go more deeper in learning. And so right now there are some small tricks that we have done here and there with autofocus, and so that could be even more machine learned system that it can actually become, right? Individual by its own ways. So those are the things that we will be further concentrating on. So that this system is able to, today it's able to handle rigid objects.
Yeah.
Right?
Yeah.
It cannot handle a wire. It cannot handle a shirt, right? Can I use the system to stitch shirts? Because that's entirely manual. Second thing, one step before that is that's from an object handling point of view, right? There is task handling point of view also, where there are tasks that you can do only with 2 hands. There are tasks that you can do only with one single hand. You can do even with a single hand, right? There are tasks you might need multiple fingers of a single hand, right? So there are those combinations. That product combinations that you're supposed to come up with is also next phase. Will be concentrating on it.
So customer will have a menu of options and they can say, this gripper and okay.
And one robot or double robots. Is the robot upside down or is it straight? Right. So those kind of things.
And this will be put on a table, or like how does it get installed in a plant?
So that's a good question, because most people don't know how robots are being installed, right? So just for that public knowledge sake, every time when a robot is being installed, there is a lot of civil work that happens there, right? What do I mean? Because they have to grout it, they have to put the screws, because when I said the robotic arm is 20 micrometer precise, right? Even if the robotic arm has shaked and then moved, everything will go haywire. It'll not work. So they have to grout and put it properly with the cement, and they have to prepare the facility to put a robotic arm. All that effort actually happens. So here, what we are doing is because of the dynamism this system has, and it can actually track its position by itself. It's actually a stand which has wheels, so you can move and keep wherever you want to keep. Right? So you don't have any of this. So today, you can move a person from one station and then put him at another station and make him work there. You can kind of move this robotic arm and then move it there. The only difference is if the customer happens to have learned the object for both of this, spent the 2 weeks for each of those objects, and spent another 2 weeks for all this, manipulation and everything. He has the model with him. He can just port the model and then move the robotic arm to the new position and then just ask him to start working on this one, right? So that's the sequence that That's how we are actually deploying the robotic.
What happens if the object is slightly changed? Say, like things get smaller and smaller. Suppose it was manufacturing a phone and the chip became a little smaller. Then would it need to be trained again?
That's interesting. So often when the geometry changes, so the same effect. This is another fallacy that most of the AI and ML systems have today: the zooming in and zooming out of an object, right? Without standardizing to it, it's much harder for most of the systems to learn at the same pattern that I'm looking at. What is the pattern that I'm actually looking at, right? So it's the same effect as an object being approached close by or an object being smaller in the same distance, right? This guy can replicate most of the designs as it is, right? Because he is not a precise machine. It's not an arithmetic machine, which is so precisely written an equation and then it says go precisely here and then touch it here. If it's 0.2 mm lesser, this fellow will just simply, the object will not mate with it, with the gripper, right? It's not like that. This guy doesn't even know how much it is. He has an approximation and he uses his sensing some way to again calculate and then understand, oh, this is the depth and this is the amount, this is how much I'm supposed to grab and all that, right? He's dynamic enough, right? So as long as the shape doesn't change, dimension of the shape remains, can change, but the shape doesn't change. The features don't change if I rotate them in different.
The aspect ratio is the same, basically.
Same aspect ratio is same, basically. If it becomes too small for the fingers, then it's a finger problem. Then it's a customization that it triggers a customization in that case, right? There's a range within which this guy can operate, right? So I have the thickness and the width of my finger, within which if it's manipulatable by a human being, this is also manipulatable by a robot. So a human being needs a gear he can pick it in his hand, but a watch gear he needs a tweezer to put it inside, right? If the watch is something, both are same exact looking worm gears or whatever, right? So that you put planetary gears or whatever, right? So in that case, this also will need a tool, or where the tool doesn't have to be detached from the hand, it can be attached. The finger itself can be translated into the tweezer, and then you can do that, right? So that change might happen to a certain extent, but whatever that is handleable within a finger, 2 fingers, whatever that is there, all those shapes are also handleable by the robotic arm.
Okay. And is there a difference in the setting of the software while you're training and while it is on the floor? For example, when you're in the training mode, does it have more autonomy? Can it do more experiments and make more mistakes? And when it goes to the factory, then the autonomy is reduced because you don't want it to do too many experiments. Like, does something like that happen?
Yeah, the whole training software is entirely different. The deployment is entirely different, right? The sequence of training is largely irrelevant the moment it just goes there, right? And we can put that there, but the sequence the industry may not be the same environment of sequence of training that we gave. Like I would have given a black table and I would have put the part, or I customized the scenario for it, or whatever that I might have done. Case part to part, whatever that I might have done. So those are not the same scenario in which you are actually picking the part or you are actually operating on the part, right? So often that deployment is very different. That's mostly from a task point of view. Whereas the training here that is happening inside the lab is mostly from object point of view, right? Understanding object point of view. Right. So once you have understood the object, so let's say I have this mouse. Am I picking this mouse to move the mouse, or am I picking the mouse to wipe the mouse, or am I picking the mouse to store it somewhere? Right. The logic will change. The motion and everything will change. The environment will change for that. Right. So that's what the industry provides. Right. The factory provides. Right. This what I'm doing with it is how I'm learning. This is an entirely. I would have clumsily grasped it. I would have done this way. I would have done that way. Or dropped it a couple of times. That all is very different, right? So that if the customer wants to buy and then use it, then it's a case where we will start thinking on it. But mostly it will be deployment scenario is a very different case for it. He will be able to handle it. Yeah, sorry, go on. It will be able to handle in variable orientations of the same object. He will know how to go precisely pick it. He will not, his intent is not to touch and feel and then learn that object, right? His intent is to precisely pick it. So that's how he's been deployed so that the algorithm also changes.
Do you see yourself becoming more like a Salesforce or more like a Windows? So like Windows is like plug and play, pure plug and play, whereas Salesforce is something in which companies employ Salesforce developers who customize Salesforce for them. So similarly, like right now you are training and sending it to the companies. Do you think in the long term it would become a scenario where companies just buy the product from you, and then they have a whole army of developers or trainers or whatever you want to call them, who actually do that last mile customization, training, tweaking,
Our
etc.
intention is to move more stronger towards like an Android and Play Store, right? Or an Apple and an App Store, right? In fact, that matches more because we also have hardware that we sell, right? So,
but then, those are consumer products, and Salesforce is an enterprise product. And, maybe you end up being more like Salesforce because of the varying needs of enterprises. And the fact that enterprises may want to change stuff, they don't want to then come to you for every small change.
I'll give you one example. So that's relatable, right? In this case, right? So every time I went to, let's say, one customer, I learned one part, and then let's say a nut and bolt, I have learned a bolt, which is a standard bolt across different industries and different customers for the bolt, right? The moment I learn this bolt, all the robots that could be there have learned the bolt because I have that model stored in my object store, right? The next customer doesn't have to spend time on learning that object. He can simply subscribe to that object store, and then he can pick that, right? But why does he want to subscribe to that object store, right? He can either subscribe to the object store or he can subscribe to only that bolt model. Either of those is his choice, right? But so that's why we want to keep that training with us. The object, the model is our IP also in one day, right? And someone else also can buy these robots and then just do set up an university where you are just simply training object models, right? You're teaching the robots to learn the objects, right? So that could be one business for someone else. We don't know. As a platform we can enable that, right? And they can keep uploading to the object store, right? And the customer, what advantage the customer has is that similarly another customer for another bolt would have asked our system and we would have trained and kept it, right? Today the customer is enabled with both the bolts. The robotic, so he suddenly his design says that, hey, I don't want to use this bolt. I want to use a little longer bolt or a thicker bolt, right? He doesn't have to go about redesigning everything. He just goes to the object store and then says that, hey, I can pick this bolt and then I can just, right? So that subscription is something that they can get into, right? That's a bigger picture. On the second, one more store also comes, which is the task store. That is a customer's IP, right? So one simple example that will again analogy that I will again take is, we have KFC franchisees that are there everywhere, right? McDonald's franchisees that are there everywhere. One who's running is someone who is here, who's born and brought up here, who learned to cook the way we would cook, Indians would cook in all of this case. But what is that they have? What is the KFC as franchise, right? It's method of preparation. They are tasks, correct? So that's beautiful, right? So when KFC can now, without having to have a brick and mortar and then having to have to figure out some guy, right, can simply upload their task model in an encrypted way, right? That whoever has the infrastructure with this robotic arm and things, a factory today, anyone who has a standard infrastructure like this will be able to borrow the task model from them, and they get paid for their invention of the task model, right? And they're able to expand. The manufacturing service companies can expand their thing without having to actively put investment from their side, right? Uploader else can agree to buy all these robots and set up it, and they can take the know-how from these guys, and these guys have an opportunity to monetize the know-how. Today, monetization of know-how only happens with the cost of all the brick and mortar being put together, right? All the infrastructure being put together, right? This someone says that, hey, I have all the capacity to run it really well, but I just give me the know-how, right? And that guy says, and that guy also has a lot. That process is very slow in manufacturing industry. Why? Because it is so risky for me to just put all my infrastructure on that particular know-how alone, right? What if this doesn't work? This know-how is not clicking with the people. What do I do then? Right? What do I do then? Since I have a standardized line, I can choose a different know-how tomorrow. I can run it for 2 months, and this is not working, right? Or 6 months, this is not working. But this infrastructure is worth for next 6-7 years, right? I can keep experimenting with multiple different
so
know-hows.
Companies, instead of exporting products, will start exporting their task IP.
Task models.
Right?
So material gets localized.
Right. Yeah.
Material largely gets localized. Only your
task IP.
moving on.
Yeah.
So So your cargo shipment will be very different in those cases. So
Fascinating. Okay, cool. Wow. I mean, I can already visualize that world which you are living in. How long before you think you'll open up a Westworld kind of a theme park?
if this, our next plan is that if this kind of doesn't go well, we will rather go writing science fiction movies. So that could be a better business for us.
So what is this priced at? What you're launching in Jan 2022?
So I'll let Nikhil answer that.
So the integrated robot with vision and grasping, roughly about $80,000 would be the cost of a robot. Today, the acceptable price point of a robotic arm in the market is anywhere between $80,000 to $150,000. That variability exists because each time the customization is different. So if there's even if the task looks very similar for a human being, depending on what that task is and what object you are handling, the complexity can just explode, and that's the higher end, which is like anything up $150,000 just becomes too pricey. So that's roughly the price point. So we would largely be focusing on a smaller target market in India, where that price point is justified because of the repeatability and the quality that the robotic arm automation inherently handles. But in a market like the US or Japan or Germany, it would be like very, very aggressive pricing in terms of even labor costs. So that's where we would most likely price the product. We already have a few OEM engagements and end customers engagements that we have in the pipeline for next year in India, and we've initiated some partnership conversations in the US as well.
Okay. And how many units do you think you'll sell next year? Like, what's your internal...
Next year would be conservative. Next year would be like our launch year, product market fit and figuring out. So probably about 20 systems is what we will target to sell. The subsequent year, we should hit at least 100 systems that we want to deploy.
Because by then customers would start telling each other, and there would be stuff for you to show productivity improvement.
The existing customers itself are a deep pipeline of opportunities, actually, right? So mostly this addressing is all mostly the pilots that we are going to sell to them, right? And the follow-on is going to be for the replication of those systems that's going to come. So that's the sequence by which this 100 number 10 to 100 is actually 0, 1 and then 10.
Right. So we already have we have identified at least 200 physical locations where the robot can be used and a customer will see value. We have been there, we've seen it, customer will invest and buy, but we will take 10% of that and deploy that in the first year, and then subsequently it will be like an expansion mode. For expansion mode, of course, you need certain amount of execution capability also to do that at that scale. Each is an $80,000 system. Certain amount of in-house assembly and manufacturing happens, integration and then shipment and then training. So you need to scale as an organization. So we'll be looking to scale to a 30-member team early 2022 by April or so, and that will allow us to execute 20 projects or 20 performance and also build the pipeline for subsequent year. We are dedicatedly targeting the US market as well to accelerate our sale and deployment.
Okay, and what is your current team size?
We are an 8-member team right now.
8-member team.
And most of these would be people either who are coding or doing the training or stuff like that, or some people who do the hardware integration. And
yeah. So 5 of us are on tech.
We have
So five of us are on tech, 3 of us non-tech. That includes me. I mean, I qualify myself most of the time as somebody who's not doing the tech. So
doing the engagement with these potential customers and
So until now, I've been doing anything other than tech.
Equally technical, but
I've taken responsibility for anything other than tech. Recently, we hired one of our colleagues from National Instruments who spent 10 years of his time at Chennai to lead our growth and business development from the sales point of view. So I'll kind of have him also support me on that while I focus more on investments, operations, business executions, and org development. Gokul does a bulk of the org development, the technology, and the design and the marketing around what we're building as well.
Are you looking to raise a Series A?
We're doing a pre-series A. We should announce something soon enough. So we'll be doing a pre-series A to go to market and expand, and then a Series A, which will be a larger round towards the end of next year.
Awesome. So, this Elon Musk talked about the production hell at Tesla. Was that something which you guys could have solved for him?
We could solve now for him to a certain extent. Yeah, to a certain extent.
So possibly the next generation EV manufacturing, that gold rush which is happening in EV manufacturing, that would be like the the wind beneath your wings, so to say, like give you those tailwinds and allow you to really scale up. Probably 100 is too small an ambition then, no? I guess there is a lot of investment happening in the EV space, and all of those folks would be like perfect customers for you, no?
Yeah. So the function, of course, I mean, we're always hopeful for a brighter future than what we have envisioned. The function right now, Gokul, I think briefly mentioned as well, right? Like we have absolutely no doubts about the customer demand and the customer requirement. The function is on whether we're able to find capital to grow and the investors to see that opportunity. Investors are likely to see that opportunity. India is picking up. US has leapfrogged with respect to the VC ecosystem, recognizing that manufacturing is a use case that is worth solving, a huge opportunity in it. India is still getting there. Manufacturing is not yet manufacturing technologies and automation is not yet a VC capital industry, largely driven by.
There's often a perception inside this. There's a bad reputation that manufacturing has actually built around. So one, their processes are very slow and they're very obstructive in the way obstructionist attitude is how they have to look at it. And the second bad rap that they often get is that in India, manufacturing is cheap and people wouldn't automate it, right? Often there is an assumption that automation happens because people are buying machinery. And they say automation is just replacing people with machinery, right? They're buying machinery to replace human labor because human labor has become costly. And they go back and then say, oh, human labor is so cheap. He is being paid only so much. So there is a long time it's going to take for someone to automate, right? But that's not the reason why anyone automates. Automation prominently comes only from the point of predictability, right? I need absolute predictability. Even if there is an error, I need to know where exactly the error is happening, when exactly the error is happening, so that I can go back and correct. Predictability of my consistency in my dimension of the product and whatever, the accuracy of the product and whatever that they have, that is also one portion, right? In fact, when I say precision, they will think only that predictability, they will think only that precision from an accuracy point of view, right? There's also process accuracy that they also want. That's a major driver for automation, right? So that understanding and in-depth putting their foot into is a problem. And I cannot also blame the VC world because mostly they come from the software industry and associated fields around that, or from a finance industry that actually comes, right? And often the finance is also not rubbing from manufacturing point of view. It's rubbing from the other world, right? So banking and other worlds that industry comes from. It's also partially a problem with these manufacturing world to come out and then start generating VCs from their side, right? There might be many LPs, but LPs don't make this as a thesis to, as a focus to say, hey, go. I might prefer investments into the manufacturing side. So that is something that tailwind hasn't caught it.
No, I think the Ola EV factory is going to change that.
Hopefully they change the perception and people start looking at them more seriously and they kind of.
No, I mean the proof is already there, no, in terms of the pre-orders that they have generated
and they are so quickly they are able to put up the factory also. So.
Yeah, exactly. I think EV, that whole EV boom is going to change. I don't see. I don't see you facing much challenge in raising funds and being even more aggressive in your targets. maybe a unicorn in 2-3 years' time.
Hopefully. Hopefully.
That's the plan.
To learn more about CynLr, their business and their emerging products, check out CynLr.com. That's CYNLR.com. This episode of Founder Thesis Podcast is brought to you by Long Haul Ventures. Long Haul Ventures is the long haul partner for founders and startups that are building for the long haul. More about them is at www.longhaulventures.com.